Welcome to Unit 5, Lesson 2, Representations of Growth and Decay. Let's revisit ways to represent exponential change. Okay, for exponential functions, b in the form y equals a times b to the x power. We're going to write our b's in parentheses. If b is bigger than 1, this is greater than. If b is bigger than 1, you will grow. If b is less than 1, is bigger than 0 and less than 1, you will decay. So we need to keep that in mind when we're talking about exponential functions. Sometimes when we talk about money, we use the word depreciate. So, all right, let's read this question. Priya borrowed $160 from her grandmother with a promise to pay it back a little at each time. Each month, she pays back 1/4 of what she owes. So if we had to write an equation for this, we have our A, our start amount is 160, and our change is 1/4. So now this is going to represent paying 160 times 1/4. But if we put this into the calculator, this will be 40 times 10, 160 times 1/4 is 40. 40 times 1/4 is 10. And 10 times 1/4 is 2.5. Now, no reasonable person would take a payoff like that. That doesn't make sense because you'd never pay it back. But if we have to understand something, our original amount equals 100%. That's our start. So if we take off 1/4 of a percentage, and we know that 1/4, 1 divided by 4 equals 0.25. And to turn a number into a percent, we multiply by 100 to make it a percent, because percent means divide. If we take off 25%, seeing what she owes will be way more important. Percent literally means divide by 100. So when we divide this by 100, we get 0.75, or we get 3/4. It's all the same thing. A decimal, a fraction, and a percent are all the same thing. So now, let's write an equation for what Priya owes, and let's see if these numbers look a little better. So we have 160 to 3/4 to each month. So we're going to use M for month. So the first thing we want to do when we write exponential functions is write the equation. So we're going to put this into the calculator. We're going to hit the y equals button. And instead of M, you're going to use the xt theta n button. And we know you know how to put this stuff in. You're going to see reasonable numbers. So let's fill in a chart. So you're going to hit second graph and pull out the table of values. When x is 0, is 160, then 120 after month 1. After month 2 is 90. And after month 3, she'll owe 67.50. So this is a more reasonable payment plan. So in the first month, she paid $40. In the second month, she paid $30. In the third month, she paid $22.50. It seems way more reasonable than paying 10 and 2.5 and 1/4 for that, because that debt will never get paid off. So the first equation made no sense. This is a better equation to use, what she owes. All right, so now we have a situation. Let's look at tuition at a college has been increasing by the same percentage since year 2000, okay? In 2012, the college tuition was $30,000 in 2012. Okay, so this is our start date, 2012. This is our A, which equals 100%. So you got to do your analysis when you read the problem. It's going up each year. So that tells me T, our time, is 1 year. So now we got to find B. So Y equals A times B to the X. So now how do I find B? Well, I'm given dollar amounts. If I take 32,448 and divide it by 31,200, or if I take 31,200 and divide it by 30,000, I should get 0.04. It's the same number, it's the same growth. So that tells me when I multiply it by 100, that the tuition has been increasing by 4% each year. Before you start to solve any problems on an exponential function, the first thing you got to do is write your equation, and you have to understand what all the things are. So if I'm adding 4%, I take my 100%, I add 4%, give me 104%. Now divide it by 100 to get rid of the percentage, I get 1.04. This is your B. This is growth. If I put 0.04 into the equation, 30,000, if I put 04 in here, the B is not bigger than 1. The function is not growing. It's going down to T or X or whatever, where T stands for years. So we figured all of that out in the problem. So now let us answer the questions. So we wrote the equation. So the 30,000 is our A. Is our A in 2012. It's our start point in 2012, which equals 100% because our start is 100%. What does 1.04 tell us? That's the growth rate. It's our original amount, our original percentage, plus 4% growth. So this is the growth percentage. The growth percentage is not the growth rate, and you must understand that. And we calculated the percent increase from year to year as 4%. Now, what does C of 3 mean in this situation? C of 3, since the input is our exponent, that's our variable, C of 3 must mean 3 years. So if we put 30,000 to 1.04 to the T, we're looking for X. You're going to put X into the calculator. If you put X, when X is 3, what's the Y? That's what we're looking for. And what we get rounding off is 33,746. So that's the tuition in year 2015, because that's 3 years from 2012, which was our start. Okay, write an expression to represent the cost of tuition. We don't even have to do this. Once you put this into the calculator, all you had to do is take 2012 and minus 2007, and you get 5. So all you got to do is go 5 years before 2012. So we want to look when X equals -5, Y was, just scroll up to -5, and we get 24,658. Y equals 24,658. Okay. A small business bought a van for $40,000. So the first thing we have is our A, which is 100% of our value. We always start at 100%, unless we're told otherwise. A van depreciates 15% every year. So now we have enough to write our equation, but we have percentages, and we don't put percentages directly into B. So what we're going to do is take 100 and minus 15%, and that will give us 85%. Then we divide that by 100, to get our B, which is 0.85. Now we're going to write 40,000, 0.85 to T or X, where X stands for 1 year. Now you might be saying, Mr. Walsh, why isn't this the equation? 40,000, 0.15 to the X. If you put both of these into the calculator, you will see great differences between the sums. This says the van, we're looking for what the van is worth, not what the van, this won't give us even what the van lost. This will give us 85% of each value each year. And this gives us worth, the first one, the red one, gives us what the van is worth each year. This one just multiplies 40,000 by 0.15, and we're losing 85% every year. And that does not give us the proper numbers. Put them in the calculator and you will see the van can't be worth 85% less than what it started out in 1 year. It's just not possible. Okay, which graph correctly represents the value? So when you put these into the equation, you will see when X is 0, Y is 40,000, and when X is 1, Y is 34,000. So now that cuts off graph A and graph C. They don't work because graph A is growing and graph C lost 50% of its value in 1 year. Graph B and C both at 1 year are 34,000, but graph B is the only graph that's exponential. It has a curve. Graph D is a straight line. Exponential functions are not linear. So graph B is the only proper choice. This does not work. Find the value of the van 8 years after its purchase. So once you put in Y equals 40,000, 0.85, because that's what the van is worth, 85% of its value. And we're looking for when X equals 8, because X stands for 1 year. What does Y equal? All right, so the van is worth about $10,900. Okay, in that same year, a business bought a car that cost $10,000 less. So if the van costs $40,000, the car costs $10,000 less. That means subtract. So the car costs $30,000 and depreciates at 10%. So we take 100%, which is our car starting value equals 100%. We take off 10%. It is worth 90%. We divide that by 100, and we get 0.9, and this is our B. All right, would the car be worth more or less than the van 8 years after the purchase? So Y equals, we're going to put this in a Y2. Keep Y1, the van. Make Y2 30,000, 0.9 to the X power. And when X equals 8, Y equals $12,914, or about that. So the car is going to be worth more than the van after 8 years.